Hello student, welcome to the class. In the previous lesson, we were introduced to the concept of functions and the linear functions in particular in the latest video. We also saw the equation of a straight line, and turns out this linear function is so important that it is not enough to have one equation for it, or to have one way to look at it. We have different forms of the equation of a line, and that means basically different things to study about that straight line, different interpretations of it, and it gives us different types of information depending on what you are looking at or how you are looking at. Okay, so that will be the study in this video, and then we will look at some real world applications of the linear functions. So we take a real world problem and come up with a linear function to represent it. When we do that, we say we have created a linear model for that problem, right? Once the model has been created, you can address the problem. You can answer the question that we are seeking for that real world situation. Okay, so let us get into it. The form that we saw previously was the slope-intercept form of the equation of line. Use this if you have the slope and the y-intercept. That's important. Okay, we sometimes, I think, I'm not sure what the textbook that you are following will say. In some textbooks, it is written slope y-intercept form, to be specific. Sometimes it is simply called slope intercept form because that's the how there you can come up with a slope x intercept form, but it is not popular. Okay, not everyone can be popular, right? uh, that was me joking. Okay, um y equals mx plus b, that b being the y-intercept. I'll write that here, where 0b is the y-intercept, m is the slope. Okay, now there's one more form which I'm not sure if we used it, but if you have not, I'm mentioning here, point slope form. Now, one idea I want to tell you here is, see, to write the equation of a line, you'll need two pieces of information always. That is a conceptual understanding. Okay, keep in mind. You'll need two pieces of information. One is the slope of the line. You need to know in which direction the line is, right? What is the orientation or what is the inclination of the line? That is the slope. Then you need to have at least one point on the line, because you can have infinitely many parallel lines with the same slope. Out of all of them, which is the one, which is my line? It is enough if I have one point, because I know the slope. If I have a one point on the line, now, you know, take all these parallel lines, among them, only one of them will go through that particular point. In fact, I can remind you one of the basic things in geometry, in Euclid's geometry, you studied in high school. There is only, and that is a postulate, right? There is no proof for it. The postulate is there is only one line um, parallel to another line which passes through a given point, not on that other line. Okay, so basically that is the point slope form. Okay, sorry, not just point slope form. That is the idea of any line. Now, point slope form exactly does that. It tells you that you need a point, you need the slope. Then you will wonder, what was slope intercept form? In fact, slope intercept form also is a point slope form where that particular point is the y-intercept. Okay. So the point slope form is like a general version of the slope intercept form, where instead of just y-intercept, you could take any other point on the line. Now, when will we use this? Use if the slope and a point on the line is given. Now, when I say a point, a general point, any point, actually, you must be aware of this. In mathematics, whenever we use this word a in definitions, a stands for any. Okay. Use if the slope and any point on the line is given. Or if, by the way, you can also use this if 2 points are given. Okay. Why? Because if you have 2 points, you can compute the slope, then use one of the points and the slope, and you have your point slope. Okay. Let me write this part, and there's something more to talk there. The equation is y minus y1 equals m, the slope, times x minus x1. And this is the very natural and commonsensical, I would say, the equation of a line. And I will show you how. If you take this here, okay, try to isolate m. If you try to solve for m there, what are you getting? Y minus y1 over x minus x1. So that x1, y1 is a point on that line. Think about it. Okay, x1, y1 is one of the points on that line. And that xy could be any other point on that line. That xy, what I wrote in the black color, black ink, is the variable point. You take any other point on the line. Now you can find the slope as y minus y1 divided by x minus x1, right? The definition of slope. And because it is a straight line, that slope should be constant, whose value is m. And that is what this equation is basically saying. So it's like the definition of the slope of a line, and it gives the equation of the line when one of the points is a variable. And you have one fixed point on that line, x1. Okay. And when 2 points are given, then you can first compute the slope. Y2 minus y1 over x2 minus x1. Okay. So if 2 points are given, first find the slope by using this formula, and then use that slope in the equation with any one of the points. In this context, also wanted to uh, tell you again, if you study literature or in some textbook, you might find a double point form, right? Where instead of m, this expression is used in front of that, formula, and it is given a separate name like 2 points form. But like it's really, if you understand it, that expression is the slope. So ultimately, it is the point slope form. So every form of equation of a line can somehow be interpreted as point slope form, right? We will talk about the general form in a second, but let us do a practice problem before that. So there is the same triangle that we had used earlier to find the distances and midpoints. Let us find the equations of those sides of that line triangle. Okay, I will do one of them first, and I want you to find the equations for the other sides, and I will give the answer here so you can check. Okay, equation of AB. Equation of AB, for that first I'm going to compute the slope, and the notation I'm using is m subscript AB, right? The slope of AB will be y2 minus y1, 6 minus minus 3 over minus 6 minus 4. So that 6 plus 3, 9 divided by 10, but there is a negative sign. I write it in the front. That is the slope. And by the way, this is you know 2 points here. Basically, we are using the second idea First we compute the slope. And now choose any one point as x1, y1. It really doesn't matter. Okay, you could have taken A or B. On purpose, I'm choosing B, which we actually used as x2, y2 earlier. That's okay. Take any one of the points. Okay. Now that's your point. That is your slope. What is your equation? Y minus y1 equals m times x minus x1. And that is y minus 6 equals negative 9 over 10 x plus 6. Okay. Unless you are asked to simplify, you can leave it like that, because point slope form is one of the beautiful forms of equation of a line. Okay. Please go ahead and find the equations of the other two sides. I will simply give you the answer here. The equations, I hope you have calculated, computed them, and you are checking them out. Now, it is possible that you used a different point in one of them, right? Or if in both cases, if the point x1, y1 that you chose was the same as I have chosen here, think, okay, what if you had chosen the other point as your x1, y1 to use in the point slope form? Equation would have looked slightly different. The slope would be the same. The y minus y1 and the x1, those would be different, right? So even though it is the equation of the same line, it is possible that it will come in slightly different form in the point slope form, right? In the slope intercept form, that cannot happen. Okay, the slope and the y-intercept have to be fixed. Okay, so it has to be the same, except maybe you can multiply both sides by a constant and get a new set of numbers, but that is only changing the scale of coefficients, otherwise the same. So one wonders, can we make this equation of line standard so that everybody writes the same equation? Okay, and which is what we will call the standard form next. Okay, so what is the standard form of a line? The standard form is when you write as ax plus by equals c. So coefficient of x, coefficient of y, and constant on the other side. And in that also, if you make it reduced, in the sense, get rid of all common factors, like divide both sides by any possible common factor and write in the lowest term, then there is only one equation, only one answer that you can have. Okay, so it is called the standard form. I'll give an example here on the side. Something like 2x minus 3y equals 6. That would be an standard form. Okay, that it look like y, 2x minus 3y equals 6. So the question then we ask is, okay, if it is in the standard form, good, but I want sometimes, some specific data, right? Or some specific information about the line so I can visualize it or interpret it in my mind. The x-intercept, the y-intercept, the slope. Here we have going to talk about formulas for that. You actually don't need us to memorize the formula if you remember the concept. Okay. X-intercept is when, what is x-intercept? The point on the x-axis. That means on the x-axis, right? If you take a line and x-intercept is the point on the x-axis, the we call it a comma 0, that point. Okay. Now on the x-axis, so obviously the y coordinate is 0, and that is the technique we use here. So you set y equal to 0 in the equation, and then you get 2x, let's say, for that particular example, equals 6. So you can get x equals 3, right? That is how you can compute the x-intercept. If you want to remember it as a formula, I'm just writing only for this one. Okay, I will not write for others because it is really not the way we were really not going to memorize the formula. If you simply plug in 0 here for y, that term will become 0. So x will be c divided by a. Think about it. Okay. Maybe when I write the formula here, the only takeaway that is useful, not memorizing the formula, but the takeaway that is useful is make sure that at the end of the calculation you have isolated the x. So if there is any coefficient for x, you need to divide with that coefficient on both sides. So you get x equals, right? Just remember that. Okay. And the same way, what is y-intercept? Y-intercept is the point on the y-axis, 0 comma b. So what would I do? I will set x to 0. Okay. Now in that example, if I set x to 0, that gives me negative 3y equals 6. Right. Now divide both sides by negative 3. You get y equals 6 divided by negative 3, which is negative 2. Hence your y-intercept is 0 comma negative 2. Okay. So not that line actually. Turns out the line is has a positive slope and it's going from first quadrant to fourth to third quadrant next. Okay. Slope. Now to get the slope, again, not a formula, but just rewriting the standard form equation in the standard form to get the slope. Okay. Which is, idea is this. Okay. The idea is when you write as y equals mx plus b, that m is the slope, right? But the equation that you have here right now is not in that form. So what will I do? I will try to rewrite it in this form. So you say that implies negative 3y equals, shift the 2x to the right side, negative 2x plus 6. Okay. I'm trying to bring it to this form, y equals mx plus b. Now divide both sides by negative 3, divide by negative 3, divide by negative 3, and what does that give you? That gives you y equals, now you have to distribute that negative 3. Okay. Initially, at least in these videos, I get into a little bit detail on my calculations just so that everybody feels comfortable. But if you are struggling initially in these calculations, you should work more on this algebra stuffs. Do some review of the high school algebra. Gradually feel comfortable. Okay. In my later videos, I will be um, cutting down on these kind of explanations. So you separate the negative 3 from the denominator into two terms. So you get 2 over 3x minus 2. And when you write it in that form, that coefficient here of the x is your slope. Okay. Oh, did I just take the equation that I wrote there here? That is interesting. Probably that's the common equation that comes to my mind. Okay. So we, through the example that I was discussing there, we already did this. Okay. I promise you, I didn't plan it. I had forgotten what equation I had written here. Okay. So we have the points 3, 0, x-intercept. I expected to do that calculation here, but we will do that for the next problem. Okay. Uh, y-intercept 0, -2, and slope 2/3. Okay. So maybe that was good. We have done the calculations there. We'll focus on the graph here. You have the point. Now to draw the graph, very interesting again. There are two approaches I'll show you can use for sketching the graph of a line. And I have seen many students, following either of them, whatever clicks to you. Okay. One simple approach is whenever you have 2 points, just don't need to do worry anything. Plot the first point, that is 3, 0 on the x-axis here, right? Plot the second point, 0, -2, that is on the y-axis there. And it is a good practice to label the points you are using. So now write the coordinates there and then join them by a straight line. If you are very puritanical, you might want to put arrows on both sides. Okay, good practice, I would say, just to indicate that the line is going to infinity on both sides. But another convention is if you draw a line from edge to edge on whatever space is available, I mean the graph that is shown, it is understood that it extends after that. Okay, unless explicitly stated, it is a line segment. Line and line segment. When you say a segment, that is a finite segment of the line. When you say a ray, it is there is an initial point and then it is infinity, goes to infinity uh, in the direction of the arrow. When you just say a line, it is understood to be line going to infinity on both sides. Okay, with or without the arrow marks. Okay, that was one approach. A second approach to sketching the graph of a line is using the concept of slope. Okay, and one point. Remember the point slope form? Okay, which would be this. It's the same line, but I'm going to redraw it. Okay, let me remove this. And let me also, let's say, let me also remove the y point. Suppose you have computed that one point on the line 3, 0, and you have calculated the slope as 2/3. Okay, so what you will do is if you go 2 units left, oh, was 2/3 or 3/2? What did I do earlier? 2/3. Okay, 2/3. And remember the concept of the slope. The concept of the slope is the change in y divided by change in x. So this, in the language we say change in y is the rise and change in x is the run, the horizontal and the vertical. Okay, rise over run. So run is in the denominator, rise is in the numerator, which means if you go 2 units to the right, 3 units. Okay, run is 3 units. If you were to go to 6 there on the x-axis, okay, mark 6 on x-axis, from 3 to 6, run 3 units, then you will rise 2 units on y-axis. So you would be here. That point would be 6, 2. Now in my graph there, you can clearly see that's going out of the graph. So if I want to remain precise to the graph, what I can do? Go, these are all also concepts, okay, that are useful to you. Go 3 units left, make a run of -3. According to this idea, you can also think of this as -2 divided by -3, right? So you have to make a rise, which in this case is down, maybe, okay, going down, um, fall, okay, fall by 2 units, -2. So you get this point here. Okay, so what I'm saying is this. Take a point and then look at the slope. Understand the slope as rise divided by run. So move horizontally by the amount in the denominator, the run. Move vertically by the amount in the numerator, the rise. And that takes you to another point on that line. And once you have 2 points, you don't have to do both of these. Okay, I was just showing any one of them, either the 6, 2 or the 0, -2. Okay, take any one of these points and then join the line, join those 2 points, that's your line. Okay, all right, very good understanding. um, Pause the video, go ahead and solve this next problem. Find the x-intercept, y-intercept, the slope, and then sketch the graph of the line, and then check with me. Okay, x-intercept, I'm going to plug in y equal to 0. So I'm going to get 4x equals 9. That gives me x equals 9/4. Y-intercept, I'm going to plug in x equal to 0. That gives me -3y equals 9. And divide both sides by -3, you get y equals -3. 9 divided by -3 is -3. Okay. For the slope part, you are going to rewrite. I'm going to write the word rewrite so you will remember. Okay. How will you rewrite? You want to isolate y. -3y equals -4x plus 9. Y equals mx plus b. I'm thinking of that, so I wrote in that form. Okay. -4x plus 9. Divide by 3 on both sides, -3. This will be 4/3 -3. -4 divided by -3. See, when you divide, you don't change the sign. Okay, you just divide with whatever number it is. So it is -3 divided by -3 on both sides. And when you divide, -4 divided by -3 is 4/3. Okay, so I'm going to use the second approach. Okay, the first approach would be to simply take the x-intercept, that is -3, 0 here. The y-intercept, sorry, not -3, 0, that's y-intercept. The y-intercept 0, -3 here. The x-intercept 9/4, which is 2.25 by the way. Okay, somewhere there, and then join them. Let's do the second approach I was saying, right? The y-intercept is -3, so take the point here, and so now that second approach is useful here compared to taking 2 points, because the point that I got here, the x-intercept is 2.25. Okay, now that plug in that, like the 2.25 means I have to divide this difference between 2 and 3 into 4 parts and then use it, and you see that's going to be a problem in approximation. You can get more or less, okay, not the exact. So what I could do instead, look at the rise over run. So here again I will write rise over run. So 9 units rise, 4 units run. That means I'm going to go 1, 2, 3, 4 units run. Okay, on the horizontally, then rise. That color is in 1, 2, 3, 4. Then rise 9 units. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's also a little bit of problem because of the size, but we get the idea. Okay, and you have those two lines. Mm, oh, I'm so sorry. I was wondering what's going wrong here. Okay, that was the x-intercept. My apologies. Here, the slope is here, 4 over 3. Okay, some of you might have caught that. Okay, um, 4 over 3. So 3 run. Hmm, I was struggling because the point was going out of the grid. Okay, so 3 run, 1, 2, 3, 4 rise, 1, 2, 3, 4. Not the intermediate points. Okay, you should not sketch them. I was just showing you the path, and then you can, yeah, by a line. Okay, and you can see that the x-intercept is almost 2.25. What the hell? But you have two precise points, that we used for sketching the graph. Okay, I'll move on. The concept of um, slope leads to the concept of parallel and perpendicular lines. If they have the same slope, right? Parallel lines have the same slope, or we say equal slopes, right? For example, your line could be y equals x minus 1 and y equals x plus 1. Both of them have the same slope 1. Okay, or you could identify them in the standard form if it was 2x plus 3y equals 7 and 2x plus 3y equals minus. Doesn't always have to be positive and negative. Okay, let me simply give another example. 5, right? And here's the thing, one more example I'll give you. It could be something like y equals 2x minus 4 and 2x minus 3 and 2y equals 4x minus 6. Or, okay, let me change that number. I'll come to that exactly 6 later. 4x minus 9, let's say. You may not see it immediately, but if you give a little bit deeper thought, these two lines are parallel. Okay, how? So the point is, you don't have to necessarily see the same numbers. Okay, what needs to happen is the same ratio. So if you see here, 1y and 2x, 2y and 4x, right? The slope is the same. The y to x, the coefficients of y to x ratio is the same. When that happens, the lines are parallel. And here is a um, method that is used, again, not to memorize as a formula, but just a concept. Okay, if your equations are like a1x plus b1y equals c1 and a2x plus b2y equals c2, let's say in the standard form, right? Then if they are parallel, what should happen is this a1 divided by a2 should be the same as b1 divided by b2 when the lines are parallel. That's how you can compare. Here you can see, 1y, so 1 divided by 2 and 2 divided by 4. They have the same ratio. Okay. When you write in the slope intercept form, you don't have to worry. In the slope intercept form, that m1 and m2, the two slopes have to be exactly the same. But when you write it in the standard form, sometimes they might look different, especially if you are trying to make sure everything is integer and no fractions. In that case, you take the ratio of the coefficients of x and coefficients of y, and if they are equal, the lines are parallel. Okay. Moving on, let's do a problem. Find the equation of the line through that point parallel to that line in slope-intercept form. Okay. Using the idea that we just discussed, but it also tells you how, in what form you have to write. Okay. Read the question carefully. Contemplate. Now when you are ready, I will discuss the solution. Okay. It is going through that point. So let's talk about what's going on here. The point is 3, -2. It is going through that point, and it is parallel to this another line, right? That I was talking to you about the Euclid's postulate earlier. It's that situation. Okay. It's parallel to this line. That is how we indicate parallelness, by the way. It is parallel to this line. And what is the equation of that line? 2x minus y equals 5. So whatever slope this line has, this line also will have the same slope m, right? That is the idea. So first of all, I need to find the slope of the given line. Okay, so that's where our work starts. 2x minus y equals 5 minus y equals minus 2x plus 5. Multiply both sides by -1. We get y equals 2x minus 5. Okay, so which tells you the slope of the line is 2. Okay, since the slope is 2, you can now use that. So m equals 2, and your point x1 y1 is 3, -2. Okay, and that gives you the equation y minus y1 is -2 equals m, slope is 2, x minus 3. Okay, that's your answer. But one step, if you want to simplify, y plus 2 equals 2x. Oh no, not one step. We have to get it in the slope intercept form, right? Currently it is in the point slope form, so we need to expand it anyways. 6, and then y equals 2x plus 2 on the other side will be -2, so you get -8. That's your answer there. Okay, in the slope intercept form. Similarly, if lines are perpendicular, a very interesting relation happens. The slopes will be negative reciprocals. I would recommend do watch a quick short YouTube video you will find anywhere. I'm sure. I'm just saying. I've never checked, but I'm sure you will find why the perpendicular lines have negative slopes. Okay, it should not take more than 3 minutes if it is a good video to explain that. Okay, perpendicular lines have negative reciprocal slopes. What does that mean? What that means is, if one of your equation is, let's say, y equals 4x plus 1, the other line should have, the perpendicular line should have the slope negative, okay, and reciprocal. Reciprocal of 4 is 1 over, right, x. Could have plus any constant, who cares, slope is negative reciprocal, okay. Um, in the example, there is more space here, so I'll talk about the exception, maybe not the example, but the exception. And you might remember this from our earlier discussion on three situations with the slope, right? They could be oblique, like these two lines, or they could be vertical and horizontal, two cases, right? Exception is vertical and horizontal lines. They are also perpendicular, but you won't say the slopes are negative reciprocals. Although in some sense you can say reciprocal, I'm just saying informally, okay? Some sense. The slope of a horizontal line, slope is 0, right? Slope of the vertical line is undefined. But what was that undefined? Actually, it was becoming undefined because of something divided by 0 situation, right? So in that sense, you can see they are still reciprocals, but we didn't say it that way, okay? So that you can say the exception. For any oblique lines, we can put it that way. For any non-horizontal and non-vertical lines, the slopes must be negative reciprocals. Okay. Let us do this example. Find the equation of the line through this point that is perpendicular to this line. Now it doesn't say in what form. So you choose your form. Okay. What I will do is whatever first form I write, I'll leave it at that. We have the point. I need the slope. So first compute the slope of given line. Okay. Slope of the given line. And how would I compute that? Negative 4y equals negative 8x, right? I write as y equals mx plus c plus 0, so I don't have to worry about that. Divide by negative 4 on both sides, you get y equals 2x. Okay, so whenever we write like this, again, don't get confused. That means 2x plus 0. So the y-intercept is 0, which means that line passes through origin. Okay, which are special categories of lines, so it's worth talking about it for a second. All the lines which go through the origin like this will have that equation y equals mx only, because the y-intercept is 0. Okay, and you can check easily that if you plug in 0 for x, you get 0 for y, so they go through the origin. Okay, so y equals 2x, and right now what we needed was the slope only. Okay, we're talking about this. The slope is 2, and because the slope is 2, slope of the required line, see, that is the given line. Slope of the required line will be negative reciprocal, right? Okay. So your equation now, that is the slope m, and the point x1, y1 given to you is negative 2, 0. So the equation will be y minus y1 is 0 equals slope m is negative half times x minus x1, x minus x1, which is negative 2, so x plus 2. Okay, and I will leave it at that, the slope intercept on the point slope form. Okay, there is a little bit more space here, so I will utilize, again, the opportunity to talk about a concept here, um, which is that this concept that the perpendicular lines have negative slopes. Um, Sometimes you have to be careful. Okay, like y equals x plus 1, the negative reciprocal you may not see if you are not careful. Okay, x and negative x, 1 and negative 1, that is also negative reciprocal. Okay, and if the equation that you have, I didn't give an example with a negative slope, suppose if you have negative 2 over 3x plus 5, then the equation of the slope of the line perpendicular to it would be 3 over 2. Negative of negative 2 over 3 would be positive 3 over. Okay, and the reciprocal, and negative reciprocal. And you can just say plus b if you don't know the value of b. Okay, and use the rest of the information. Actually, that is another approach to solve that above problem, which I'm not getting into. Okay, you can write the general solution of equation of the perpendicular line like this first, and then plug in the point to compute the value of b. I'm sure some of you have done that before, or you feel comfortable that way. Okay, so this should be the slope of the, what I'm writing here would be the slope of the perpendicular line. Then use the point negative 2 comma 0 to plug in there and calculate the value of b. Okay, I will move on to the linear models part. We'll take these problems and convert them into linear models. Okay, the average hourly wage adjusted to $1982. You understand that what that means? Okay, in our times when we are in forever inflation situation, this adjusted $1982 means, see, what you can buy with money in um, 2020, 2020, let's say, will not be the, like, you would be buying more with the same money in 1982, right? Or with the 1982 money, the amount of money you could buy only less in 2020. So how would you compare the incomes of people across the years? You have to bring them to the same scale, kind of, you have to have some conversion so you can compare. Somebody earning now, let's say, $60,000 a year in 1982 might have the same quality of life as someone earning 80,000 or 100,000 in 2020 or 2025. That depends on how that at the exact values will depend on the exact data that I'm giving the idea. Okay, so the average hourly wage was 7.66 then, and 8.27 in 2009. What that means is the average hourly wage increased, not just across the years, but in the same scale it increased. Okay, so it was a little better in 2009. Okay, find a point slope form of a line that passes through these points. First of all, uh, point slope form in equation, right? So first we need to find the slope m, which would be 8.27 minus 7.66 y2 minus y1 divided by 2009 minus 1990. Okay, so the slope I calculated to be 0.0321, and now your point slope form would be, take any one of the points, let's say y minus 7.66 equals 0.0321 x minus 19. Okay, that would be the equation. What's the second part? Interpret the slope. Okay, to interpret the slope, we'll go back here and look at it. The slope is 0.0321, but what would be the unit? It would be dollars per year, right? That means the hourly wages increased on an average by 0.0321 dollars per year. Okay, now, okay, not that quite that way to put it. The best way to put it would be the hourly wage, the hourly wage increased by $0.03 every year. That's the better way to put it, which is what? 3 cents. Okay, 3 and decimal cents, 1/5 of a cents. Very little growth, you would say, right? Okay. That is the interpretation of the slope. I will write in sentence. Hourly wage increased at the rate. The slope is a rate. That's very important. At the rate of approximately, 3 cents per year. Um, I just want to double check. Okay, I'm a little bit surprised. It's so low. Is that really the case? Okay. It was okay. Actually, it was less than $1, right? In those many years. So yeah, yeah, only 3 cents per year. Okay. Hourly wage increased by 3 cents per year. Okay. Use the equation from part A to approximate the hourly wage in 2005. Compare it with the actual value 8.18. It seems the actual value is 8.18. You can compare with that. Okay. How? Use the equation. So y of 2005, okay, would be from that equation. Okay, so what do we get? Y minus 7.66, right? So y will be 7.66 plus 0.0321 times x, in this case is 2005 minus 1990. Okay, and calculate that. Okay, I calculated it to be 8.18. 8.14. Okay, so $8.14 per hour in 2005. Predicted by this model, the actual value is 8.18. So you can say, we're quite close. Okay. Next question. Give the equations of the vertical line and a horizontal line passing through this point. Okay, this is a concept question. We don't need much space, so I haven't provided much space here. The point is here, -2, 10. Okay, not to the scale in the second quadrant, right? So the vertical line will be this, horizontal line will be that. The point is -2, 10. Okay, I think I should zoom in to show it clearly. -2, 10. So the vertical line has the x value -2. The horizontal line has the y value 10. Okay, so as simple as that, the equation should be the equation of the vertical line is -2 vertical line and y equals 10 horizontal. Okay. Next, find the equation of the line through that point and perpendicular to x equals 4. Another concept question. Perpendicular to x equal to 4. Now remember, x equal to 4 is a vertical line. Okay. So what is the line we are looking for? I will write that here. The required line is horizontal, right? And it is passing through the point 1 comma -4. So its equation is y equals -4. Okay, the equation of a horizontal line is y equal to constant going through -1 -4, so y equals negative. Okay, here the question is rewrite this in the form y equals mx plus b. Okay, that is for your practice. Pause the video and try to do it, okay, because we have done this work before. So 2y equals -7x -7 divide by 2 on both sides. That will give you y equals -7/2x minus 7/2. Okay. Similarly, the next problem, 3y will be equal to 5x. Y will be 5/3x plus 0 in mx plus b form. Okay. Next question. Find the equation of the line that is perpendicular bisector of the line segment connecting that and that. Okay. So you are given this line segment from where to where? To -4 to 10. And what is the equation that you need to find? Perpendicular bisector. So it bisects, it's in the middle and is perpendicular to this line. Okay, so that, if you think about it, gives you both. It gives you the point through which it is going and also it gives you the slope. How? The point is through the midpoint formula, 2 plus 10 divided by 2. 12 divided by 2 is 6. -4 plus 2 is -2. -2 divided by 2 is -1. So the midpoint is at negative 1 comma 6. Okay. Now I spoke the calculation. Please write it for your understanding if you need. Okay. X1 plus x2 divided by 2, y1 plus y2 divided by 2. And what about the slope? First, we need to compute the slope of the given line, which will be 10 minus 2, 8 divided by 2 minus 4, which will be 2 plus 4, that is 6. That will be 4 over 3. So the slope of the required line M2 would be, because it is perpendicular, negative reciprocal, right? Now I have the two pieces of the puzzle here, slope and point. Okay. So your equation would be y minus y1 is 6 equals negative 3 over 4. X minus x1 is negative 1, so x plus 1. That would be your answer. Okay. With that, we did solve many problems here. Don't forget to be doing the homework as soon as you can. Okay. I'll see you in the next video.